Hi students, this is Ramya from Pharmatutes and today I am going to explain about benzoin condensation. It is an organic reaction in which nucleophilic addition occurs between two aromatic aldehydes, example benzaldehyde. In the presence of cyanide ion, we can use potassium cyanide as a source of cyanide ion to give benzoin, that is alpha hydroxy ketone. It is a reaction between two aromatic aldehyde in presence of cyanide ion to form benzoin. So this is benzaldehyde, which is aromatic aldehyde. Potassium cyanide is a source of cyanide ion and it is benzoin. This is the structure of benzoin. So 2 aromatic aldehyde benzaldehyde, 2 moles of benzaldehyde in presence of potassium cyanide undergo nucleophilic addition to give benzoin as a product. So this is benzoin condensation. Now we will see the mechanism involved in the benzoin condensation. So let's see the mechanism. So in the first step, benzaldehyde is attacked by cyanide ion. So cyanide ion acts as a nucleophile. Cyanide ion is a strong nucleophile. Cyanide ion is a strong nucleophile and it attacks the benzaldehyde. See, here you can see, here you have electron deficient carbon and the electron rich oxygen. So now cyanide ion will attack electron deficient carbon atom. So it will attack electron deficient carbon atom. So this is the first step, that is strong nucleophile, that is cyanide ion will attack the benzaldehyde. So now in the next step, this is the first step, and in the second step, so this proton, so a removal of proton and addition of proton occurs together in this step. That is, this proton will go by taking the electrons, by giving the electrons to the carbon, and this proton removed and it will attack the electron rich oxygen. So let's write the product. See, this hydrogen will go as a proton and that will attach to the oxygen and you will get a negative charge. This is cyanohydrin. This hydrogen will go as a proton and it will attack the electron rich oxygen to form a carbanion, that is cyanohydrin. So because of the cyanide ion, that is electron withdrawing group, this carbanion is highly stabilized. So because of the cyanide ion, the cyanohydrin anion carbanion is highly stabilized carbanion. So the cyanohydrin formed, which will attack the another molecule of benzaldehyde. So where it will attack? Carbanion always it will attack the electron deficient carbon. So this is a stable, cyanohydrin is a stable carbanion. It will attack the electron deficient carbon and you will get, see, this oxygen is electron rich. Let's write this hydrogen here and now this will attack here. So this is the intermediate obtained in the benzoin condensation. Now proton shift occurs. Proton from the hydroxyl ion gets shifted to electron rich oxygen. So now proton will get shifted. So here you will get O minus and cyanide ion. And now this electron rich oxygen will give electrons, and this cyanide will go as a leaving group. This cyanide ion will go as a leaving group, and finally you will get benzoin. So you will get benzoin. So this is alpha hydroxy ketone or benzoin. So this is the product obtained from the benzoin condensation, and you can see, so in the first step cyanide ion will attack. So here cyanide ion acts as a nucleophile. So in the second step cyanide ion acts as a stabilizing agent. It will stabilizes the carbanion, and here in the last step cyanide ion goes as a leaving group. So this is the role of cyanide ion in the benzoin condensation. It acts as a nucleophile, it stabilizes the carbanion, and it goes as a leaving group. So it acts as a nucleophile, it stabilizes the carbanion because cyanide ion is a electron withdrawing group, and finally it acts as a leaving group to form benzoin, and this is the product obtained from the benzoin condensation. So this is benzoin condensation. It is a reaction between two aromatic aldehyde in presence of cyanide ion, which is a strong nucleophile, to give benzoin. So this is about benzoin condensation.